Bon, bonjour et bienvenue à cette émission dans laquelle on essaie d'apprendre le langage de programmation Zig en faisant le tour de ziglearn. On est rendu au chapitre 2, on a fait tout ça, on est rendu à peu près ici. Puis là, on arrive dans des bouts que ce que je crois comprendre, ça peut devenir plate un peu. Alors, je vais essayer d'aller vite, mais pas trop vite quand même, parce qu'on va essayer de comprendre ce qui se passe. La dernière fois qu'on s'est parlé, je suis en train de faire ça. Et puis, ben, c'est ça, on avait les arguments. Puis là, j'ai enlevé les affaires ici. Là, finalement, je vais pas mettre tous les trucs en haut. Je vais quand même garder ça. Seule chose que là, j'ai viré des trucs dans lui. On sait que il y a ça ici que j'avais pas bien lu l'autre fois, mais c'est quand même cool. Ça va trouver les leaks plus facilement si on met ces deux-là à true. Mais c'est pas obligé de les mettre à true. Là. Mais si j'ai des segfaults à cause de la mémoire que je suis mélangé, là, je vais pouvoir les remettre à true. Mais je pense que ça sert à rien de mettre ça à true tout le temps. Pas exagérer, puis ça fait vraiment. C'est plus compliqué, puis ça. Je sais pas. Peut-être que j'aurais toujours le laissé à true en fait. Je sais pas. Aussi, là, tu vois, dans mon VS Code, là, j'ai mis le terminal en bas maintenant. Puis on voit mieux. Je vais moins me gosser avec ça. L'autre chose, je me disais, là, pour le plan de ce que je suis en train de faire, c'est la seule raison pour laquelle je fais ça, évidemment, comme vous savez, c'était pour quand je commence à m'enregistrer puis je commence à parler, ben, je peux pas juste regarder Internet. Puis là, je peux me rester. Ça me force un peu à faire les choses. Ça me force à me forcer si je me filme, je le mets sur Internet, même si j'ai aucun viewer. Hein. Je m'entends que si vous regardez ça, ça serait vraiment bizarre. Puis là, l'autre chose que je m'étais dit, c'est que peut-être qu'un jour, là, je vais me forcer, puis je vais être meilleur, puis je vais faire ça mieux, puis plus short, puis pour être plus utile, il faudrait que je le fasse en anglais aussi. Peut-être qu'un jour, je vais commencer à parler en anglais à la place, puis je me disais peut-être que je pourrais commencer tout de suite juste pour voir si je suis capable, si je suis assez bon pour parler en anglais. Alors maintenant, je vais switcher en anglais. Je me demande si je vais être capable être assez bon pour parler en anglais puis expliquer des choses en même temps. So we'll switch in English now, sorry. So I'll try to explain stuff in English instead, just to see if I'm good enough for that, to see if my accent is not too intolerable, to see if I can explain this. So this is a program where I try to understand the Zig language by following a tutorial in front of you. I never seen this before, so it's not like I'm a teacher or something. I'm literally just learning as I'm going. So I'm here now, and I'm trying to understand this code. Now I'm going to explain the way I'm going to proceed. So I never understand anything that I do if I don't type it and spend a lot of time. So it's going to be very long and boring for you. So I guess if someone really wants to watch it and do something for it to be useful, you actually need to reproduce what I'm doing and try to do it at the same time as me in VS Code. So, and at some point I'm going to make a tutorial to show how I set up my VS Code and how to download Zig and all these things. But for now, let's just try to see if I'm good enough to explain things as I go. So I'm going to just say, copy this and try to understand as I go. So I'm going to say const contains iterator. So the goal of this is, the struct is to contains iterator. So it's here we will implement a custom iterator. It will iterate over a slice of strings, yielding the strings which contains a given string. So we make an iterator. The goal of this iterator will be to give us the strings that contain a given string. Okay. So the way this struct works, so there's strings in there, which will be a slice of slices. So it's like a two-dimensional array of U8, which are characters, could be characters, needle const U8. So we have this array of strings, and we're gonna find this string. So this is a string. So I won't explain everything. I expect that even if I just started talking English, and if someone really watches this and it's the first video, it's gonna be weird. But anyway, so this is an array of a slice of slices of U8. You'll have the index, the size 0. Okay, not sure what will be used for. And then we have a function. Function next takes self contains iterator. Maybe a slice const u8. Const index. Okay, so it's probably very boring for you to just watch me copy paste this as I'm trying to understand and talk at the same time extremely slowly. But yeah, that's what that's what I'm doing. Sorry. So one thing is that, yeah, we are going to modify myself, so it needs to be a pointer. So that's a choice. Every function, you decide if you want to be const or not by doing either pointer or not. Maybe a slice of const u8. So we might not return a just null. So that's the end. At the end of the iterator, we give a null. Okay. Self index. So index const. I really don't like this. Why would you like say this? Like, that's sad. Let's call it I instead. Const I, which is another usize. I don't know why. So now the goal is to go through 4 self strings from I to everything. So starting from here. So we're gonna loop through this. So this is the slice on which we're gonna loop now to find the next needle. So we start at here, from here. Like we're gonna start from here. Start from index, and then we're gonna loop on this. So like this sub array, which is another slice of slices, which is this. And we take this slice like this. That's like this. Okay. And then we loop on this. So as you can see, the way I work is I just make the code like more verbose. Wait. This subarray. So we start from there and continue to the end. So I could say like this len at the end. But this is how we make a slice from some index. Like a view this does not copy memory. This is slice, so it's like a pointer but with a length. And so we loop on this and get the string. So what I don't like is now that this, we don't know what it is, but it's a this. It's a slice of u8, so it's like a string, but like the word string here, it's like, it's not a reserved word, it's just this variable name. Subarray self index plus equals 1. So we increase index, this index plus 1, and then if td mem index of, a new thing that I didn't know about. So this is what this is. Index of takes a type a haystack, a needle, index of pos, t haystack 0 needle. What? Index of pos. Okay, so say like it's like find something in something. So find the index of the type is U8. The thing we're searching inside of, like the haystack, is string and self. Needle. That's the needle we're searching for. And we start from here. Let's see. We start there. Okay. And we don't care about what it is. So we take the what? What? Index of returns maybe a U size. Okay, so I'm gonna do var index of needle in sub array, which is maybe a U size, which is this. And say if this is not null, because I prefer in this like it's just less code, but like I think for a newbie or for a beginner, even if that's the zig way of doing it would be to do this, still want to make it extremely clear what's happening. Big haystack of rings. Okay, small, like the end of like haystack, like remaining haystack. I'm gonna loop on this, gives us a string. Start from index, it's the current index. And we're gonna, for remaining haystack, return string. So as soon as we find one, we return it. We return this string, this current string. Like, let's call this current string. We look for, look in the current string. So the goal is to, like, this is what we're doing. Yielding the string which contain a given string. So that's what I, like if it contains this, okay, return string, okay, and or else if we don't find it in this for, so here we next needs to return something, so we return null, because we might return null. So since none of them has undefined, we need to initialize somehow. So the only one we started with 0. These need to be initialized as we create this in the main. Okay, so in the main we're gonna say var, we'll have a stack, so var const a stack, so big list of strings. We just say it's this, but we need to initialize it somehow. So we don't know how many there is. Const UI, and this is how we initialize a list of strings. 1, 2, 1, 2, 3. Okay, this is how we made this little list of strings. I don't want to put it right there. That's why I'm trying to. Can I do this? This is not a thing. But this, I need to be equal. So this works. This is how we do it. So slices. So it's going to be an array of slices. An array, it's not like a slice. An array, the memory is actually there, but each of these are slices. Slices, the memory is not there. Memory will be like those are string literals, so the memory is like in the program memory somewhere. It's const. So the actual type of this is like an array of 3 slices of const u8. So that's the type of the haystack. The actual type has the number here. And I can't do it like this because that's not the syntax for a type. This does not compile. So will this compile? He'll say this is not a type. He's gonna say error. Yes. So I need to know it here. That's why we normally don't do that. And this compiles. Not compile because alloc, we're not using the allocator probably. Now we call the function by doing our iter contains iterator. Now we initialize strings equals a stack. So we don't want a stack. We need a slice. We need to convert this array into a slice. So the array of slices into slices. So to get an we could do something like haystack 0 like this. We want this, and then needle the string e bozo. I say bozo like this. We want to return this string and this string because it contains the string bozo. So that's the concept here. Find something, we return it, we increase the index. So this or this is the same, I think. Slice is like a pointer. Now we look at what it is. So print. So let's just print our first result. Return next and print it. Print it like this. So what we return is this. So we need maybe a slice. Maybe a slice. What does this look like? What happened? No, not happy with that. Strings, it's not strings, it's big haystack of strings. Remaining haystack. Okay. We need any. And we're here. So we see what we have. Okay, create this. Big haystack of strings like this. Then 3. Okay. And go in. Book. Can't see things necessarily. A little bit. Yeah, 0. Now remaining haystack looks like this. It's everything. First one is this one. Return strings look like this. Then 7. Increase the index now. Index of needle is subarray. Click, and what it is, it's the index is 2. So if it's not null, we don't care where it is, we just return the string. And we print it. And did we print something? Yes, we printed this string. So we'll get it if it's not null and print it with an S instead. And then again, second one a little bit faster. Print. Just do iter next, maybe, and then we probably want to print iter next. Probably if I do this, it's gonna crash. Let's see that it prints null at the end. We'll see the two ones that we want, one after the other. This one and this one. 2 won't print because it's not in the haystack. And we see these 2 words. Can we see them? Tuk tuk null. And if I do this, what happens? It's gonna crash because I'm trying to unreference a null. Panic. Attempt to use null value. That's what I wanted to see. And that's it. That's me trying to understand this little piece of code very, very carefully, because I'm not so smart, so I really like to do things slowly. Custom iterator, blah blah blah. Formatting specifier. So that was it. We've successfully did this very simple thing. Bravo, bravo, it worked. Anyway, let's forget about all this. We know how to make a little iterator and return maybe something when you finish. No, so that's how you make an iterator. It's so easy, very brain dead. Like return stuff, remember where you are. That's very easy. So let's say if I wanted to loop using the iterator, like I wanted like just loop. Normally what people would do is just while iter next. So while takes a boolean, but if it's an optional, because this is an optional, if it's an optional, the while loop actually gives you something like a for loop that would iterate on things. It gives you the result of taking the value of the optional if it's not null. So when it's an optional, like it's gonna go in and gives me the current string. So just some string, and I can just print it. Print this string like this, and yeah, it's a string, so we say s here, and it's gonna stop at the end. So this is how we use an iterator actually. Boom, boom. That's fun. That's cool. It's not too bad. Like while has a result, like a thing that you can use for each iteration of the while. So that's how you while like a function that gives you like a result. An iterator, you can like use it here in the condition of the while, because an optional is like a boolean for the while, but it gives you something. That's pretty cute. That's a fun way to use iterators. I really like it. That's actually very interesting. Thank you for specifying that and saying that it's a thing. So enough of that. Like actually kill this. We don't care anymore and go to formatting specifiers. FMT provides option for formatting various data types. FMF slice hex lower and slice hex upper provide hex formatting for strings as well as click for ints. Hex upper, hex lower. Okay, it's very boring subject, but let's do it anyway, because I don't want to skip things that I think are boring, but in the end it's going to be useful. I don't actually know that it's going to be boring. It looks boring. We'll see. It's probably very boring. Let's still do it anyway. It's going to be this u8 undefined. Buff print. Really? We want a buff sprint. Const buff print std fmt buff print. Buff print. It's a function. It's this function. Buff print. Buffer print. So come time type buff print error. Fix buffer stream. First writer, blah blah, get written. Get written. It's gonna be some number. No, it's a buffer. I don't know what this is, so buff print. This is just like print. buff print into a buffer b. What? So buff print takes as argument the buffer in which we're going to print. So we have this. We're going to print into this array of 8 on the U8s. 8 U8s. So we're going to need 8 U8s. We're going to print into that. So this function will print into it. We take as argument a comp time format. This is just a string. So this is the little string I'm giving here. And then args is an anonymous struct like tuple thing, like unnamed anonymous literal tuple thing with a dot, but we give just one thing. We give this number for some reason. And this is f. So we print this into the buffer. And we don't like to do just these things because we want to see things. So I don't do the expects, equals, and tests, everything. I want to see things with just printing like a noob. And now I just do give me like what it looks like as a string, this thing, like the actual buffer. Can I do that? B as a string. It's gonna show this or not. Why would you give me errors? I'm trying stuff, so I need to. I have to use the result, but because this returns something, I need to say to the compiler that I know what I'm doing and I want to trash what's coming in from the function. Okay. Hey, it recalled the thing. Beautiful. And if it's a small x, okay. It's gonna be the same thing with small letters. So that's like we're learning the different format specifiers that we want. We know that these are available somewhere, like the x and x output memory value, x decimal distant notation. S is for pointer to me, and C pointers of U8 print as a C string with 0 termination. For slices of U8, print the entire slice as a string without 0 termination. Floating point value in scientific notation. D, numeric value in decimal notation. B, integer value in binary notation. Binary notation. Interesting. So that's the one we just did. X lower. Okay, let's forget about this one and just say std fmt slice x lower and give zig and say we want to print this as a string. Anyway, we always print as a string. It's just this. We could just use the print directly. I think it's because you want to expect things. So maybe we don't actually care about the buffered print crap and just do it like this. Just put this in there instead. I don't actually need all this. We just want to understand what this is. This is compiler. This it did catch missing closing. Wow, nice compile error for a string that is messed up here because it's not at compile time. It's beautiful. Wow. What? Slice, hex, lower, zig. It's this. If it's just this string, it's gonna write what? 61. If it's a Z, 7A. Just a big Z, 5A. And so that was the 5A here. And we had the other ones. Okay. So that's what's written here. Beautiful. So slice X lower returns a formatter for where every byte is formatted as pair of lowercase hexadecimal digits. Okay, D perform decimal formatting. Okay, D. We're gonna just see the number. And then E is a scientific method. Beautiful. Okay, I think I'm gonna stop. Okay, goodbye.